Okay, welcome. This is Chapter 1, Section 2, Displaying Quantitative Data with Graphs. My name is Todd Fidel, and this is from AP Statistics. In this section, we're going to make and interpret dot plots and stem plots of quantitative data. We're going to describe the overall pattern of distribution and identifying out any outliers. Identify the shape of the distribution. I'm going to make and interpret histograms of quantitative data. I'm going to compare distributions of quantitative data. In the last section, we were introduced to the categorical data, and we looked at how we display that with bar graphs and pie charts and such. This time we're going to look at some other graphs. Okay, so one of the simplest graphs to construct is called the dot plot. Each data value is shown as a dot above its location on a number line. So to do this, we draw a horizontal line, label it with the variable name. We scale the axis from the minimum to the maximum. We make a dot above its location, where it's located above the horizontal dot plot. And so it's a very simple type of thing. If we take the data from page 25 on the goals scored during the 2012 U.S. women's soccer team, so these goals are just sort of in this data table in no particular order. And so then we just take each one of these there and put it right above the number and the number line. This number line, you don't have to do just the even numbers. Could be the odd numbers in there. But just take every one of them and put it in a dot. Very simple. Be careful. Make the dots large enough so they can be seen. And try to line, make it nice and neat so it can be easily read. So you should be familiar with this because we made that on the first one. Okay, so now that you can make that, we're going to look at how we examine the distribution of the quantitative variable. The purpose of the graph is to help us understand the data. That's the reason why we do it. After you make the graph, you can always ask, quote, what do I see? If we just quickly look back on that. So what do you see? And we're going to answer that question in a second. You can see where most of the goals are situated and everything. Okay, so here's how we're going to examine the distribution of quantitative variables. In any graph, look for an overall pattern and for striking departures from the pattern. So that's the first thing you do. And then we're going to describe the overall pattern by its shape, by its center, and by its spread. So the shape is, what general shape does it have? The center, we're going to look for where the center of the data is, and we're going to look at, how the data is spread out. Then we're also going to look at individuals that fall outside the overall pattern. These departures are called outliers. To help you understand, this textbook uses a saying that says, don't forget your socks, which stands for shape, outliers, center, and spread. It's not in this order that we introduced it, but it helps you make sure you are describing everything about it. And those are the four things that you're going to be that I'll be looking for when you turn in work to me, as well as on the AP test. That's what they'll be looking for. So let's look at page 26. Here's an example. Whoa. So this example on page 26 comes from the highway miles per gallon. And so this is the data that we looked at before, and here's a dot plot of that. And so you can compare this to the data table. It's actually on page 27, but the introduction is about how they got the data. So first off, let's describe the shape. So we look at this shape and we can see that there's a dot out here and there are some dots out there, but we want to describe it this way. There's a peak about 30, so you see that's this is more than anything else. Most of the data is between 24 and 34, so between there and there. This would be 25, this would be 24 and a half. I don't like that they don't have enough numbers here, so that we have to know the data to know that that's a 24. But anyway, on your dot plot, maybe you'll put more of them on there. Next, we're also going to note that there are large gaps above and below the center point. So there's or between above the 24 to 34. So there's a gap there and a gap there. So that's how you describe the shape. Where's the peak? Where's most of the data? And are there some gaps in there? Next is describe the center. It looks as though the midpoint is about 28, which would be right in here. You could count how many data points there are, and so you just want to sort of give an idea of where the midpoint is, and then put what that represents. That represents that the typical miles per gallon would be 28. So give a meaning to the midpoint. Next is the spread. The spread is from 18 to 48, and you can look at the data table and to see that. And then the next question, are there any outliers? So it appears as though this 18 is outlying from the main group, as well as the 40 and the 48. We're going to have a numerical way to figure that out in the next section. For right now, we're just going to basically do that. So let's review real quick how we describe the shape. When you look at the distribution shape, we concentrate on the main features. Look for symmetry, and then look for what's called skewness. Symmetry, of course, means that the left and the right are both mirror images of them. A bell curve they talk about is symmetrical. But some data is not. Look down below, you see the first one on the left. It looks pretty symmetrical. This one, there's fewer on the left than on the right, so we actually call that skewed left because there are fewer. The idea of the term skewed means that that's going to change things, and so the further out these are, then the more it's going to change the average and such. And then skewed right is when we have a tail over there. So study the difference between skewed right and skewed left. And as we go more through more of the calculations, you'll sort of understand better. You can be able to look at graphs and say, oh yes, the single dots over on the right, it's going to change the average, so that means that the data on the right is skewing the data, so we call it skewed right. It's a pretty strange definition. So let's take a look at the goals dot plot, and then let's go through our SOCS to see to describe it. So the shape, we can see that there is a main peak at 4, right? These two are about even, so we'll call it the main peak. The cluster is between 0 and 5. That's the main cluster. We've got these outliers going out here. There's a gap between 5 and 13, so that's going to change things. It's not symmetrical, so what do we call this if it's not symmetrical? It's going to be skewed right. That means the the data on the right is going to change the values of the average and such. It's not symmetrical, skewed right, as you just said. What does that tell us? Well, think about that for a second. Yeah, so most games rather, there were 0 to 5 goals, and the most common was 4, and so that's what the shape tells us. And there were these sort of outliers out there, which we will address in a second. All right, let's now do describe the center of the dot plot. We can see the midpoint of 25. There's 25 data points there, so the midpoint would be the 13th. So then we count over 13 from the left or 13 from the right, and we end up on 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? That would be the middle of the data. So we would say the midpoint is there. The spread, so this is the other S in SOX. The spread of the goal, it would be from 0 to 14 goals. That's an easy one. So that's just kind of the minimum and the maximum. And are there outliers? Well, it does appear 13 and 14 stand out, and we'll look at the calculations on that in the next section. So yeah, so that's the way you go through the data and look at it. Let's for a second go ahead and take a look at your data. So here's your data. Let's do the same thing and describe your data. Notice I neatened it up some from when we took the data. So let's describe the shape. Okay, so we say, all right, there's a peak at 4. The data is clustered between 1 and 6, so it's pretty good. And it's basically symmetrical, right? It's not a bell-shaped or anything like that, but it's somewhat symmetrical. I'm going to go in the order of SOX. Are there outliers? It doesn't appear to be. So the 6 wouldn't be any outline because it's only 2 away from the center. And the 1 wouldn't be an outlier. It's only 3 away from the center. So there aren't any. The center would be between 3 and 4. So you could count how many there were, and then you could figure out, but I know it's the center would be 3, I believe. And the spread, is between 1 and 6 from there. So there is the SOCS that helps you figure out that. Okay, so now we're going to compare distributions. Some of the most interesting statistic questions involve comparing 2 or more groups. Always discuss the SOCS whenever you're comparing. So let's take a look at page 30. This has to do with household sizes. UK versus South Africa. Now we're going to compare the distributions of the household size with these 2 countries. You can see, in South Africa, the data is spread out from, say, 3 all the way to 26 or so. We don't have anything to go on except this. And for the UK, it's roughly symmetrical. This one looks like it's skewed right, and this one is symmetrical. So that's a way of comparing the 2. They are both unimodal, which means they have 1 peak. We'll talk maybe more about that later when we see data that has multiple peaks. The center of the South African students tend to be larger, right? So the center of this is over here. Just eyeballing it, it's basically over in here. But in UK, the center would probably be on that peak, or maybe over here, probably on that peak. The spread The spread from South Africa goes from about 3 to 26 or so, and UK, the spread is like 2 to 6. Yeah, we're looking at household size here. And any outliers? Well, this appears as though in the South Africa there's an outlier of 26. And it doesn't appear like there's any outliers for that. So that's a way of looking at of that. Be sure that when you're comparing distributions that you're using the words greater than, less than, about the same, so that it's very clear. You can't say one is different than the other, because that doesn't work so well. You have to say exactly how it differs. Okay, so now we're going to look at a different kind of graphical plot, and it's called a stem plot. It's sometimes called a stem and leaf plot. I know in our Algebra 1 book they call it a stem and leaf plot, but in AP we're going to call it a stem plot. Stem plots usually give us a quick picture of the distribution while including the actual number. So in the dot plot, we couldn't see the actual numbers. To make the stem plot, we're going to separate each observation into a stem, all but the final digit, and a leaf, which will be the final digit. You'll see how that works in a second. We're going to write all possible stems from smallest to largest in a vertical column and draw a vertical line to the right of the column. We're going to write each leaf in a row to the right of the stem, and then we're going to arrange the leaves in increasing order. And then, very importantly, we're going to include a key that explains the context of the stems and the leaves present. Let's take a look at one. So here we have some data. These are responses of 20 female AP Stats students to the question, how many pairs of shoes do you have? So we're going to construct a stem plot from this. You notice the data is not in any particular order. It's just kind of put in there. So we're first going to, these are called the stems. So we look at the data. We have from 50 down to 13. So you want to figure out where the the highest and the lowest is. And then the 10 and the 50, 10, 20, 30, 40, 50 become your stems. Okay. We then are going to list, we can then go through each one of them, and we can list the what's called the leaves, or the next digit. So we put the 0 in there, we put the 6 here, the next 6, the 1 next to the 3, the 7 next to the 5, and so on. So we're going through each one of these, and we are constructing all these leaves. All right, so you put the 10's value here, the 1's value there. If it ends up that there are, if these were hundreds, that would be okay. You just always put the single digit over on this side. Then it will look like, 13, 12, and things like that over there. Okay, we then rearrange them from least to greatest, and so then this is the actual stem plot, and then we add a key. So we pick out any one of these. It doesn't matter which one it is. We put 4/9 represents a female student. We got that from the description here, who reported having 49 pairs of shoes. So be sure you add that. That's one of the things that is left off most often from students, is not putting the key in there. Okay, so when data values are bunched up, we get a better picture of the distribution by splitting the stems. So in this we can sort of, it kind of looks like a bar graph if you look at it sideways, right? We've got that many going up there, that many there, and so on and so forth. But when we have a lot of data, that's what this is talking about, then we split it up and we do what's called a back-to-back stem plot. or no, rather, we split the stems. We can also look at more than one distribution by doing a back-to-back stem plot. So let's take a look at this. So we have males and female respondents here, and this has to do, this is the same number of pairs of shoes. And so first we split the stems. So we are going to take out, and the reason why they did this is because there are so much data that the stem or the leaves would end up really long out there. So we're just going to split them up a little bit. So we first look at the males, and then we so then we look at the males on the right and the females on the left. So then we have this back to back. So it's sort of like a bar graph on, where this is the bottom and these are going up, and then for the females this would be the bottom and then going up, which is kind of easy to tell. It's like you can see from 4 to 8 there are a lot of males but no females, and that had that many pairs of shoes. And then you can sort of see, and don't forget we have to put a key in there to indicate what all this means. Okay. The next thing we're going to look at is called histogram. So the histogram will take quantitative variables, and sometimes they would take them as groups. So a graph of distribution may be clear if we group them together. The most common graph of distribution is called a histogram. Okay, to make this, we divide the range of data into equal widths. We find the count or the percent of the individuals in the class. We label the axes and we draw the histogram. The height of the bar equals its frequency. Adjacent bars should touch unless a class contains none. So this is like a bar graph. In fact, it is a type of bar graph, but we are going to you're going to see how it's slightly different than a regular bar graph. Okay, so here's some data that represents the percent of residents from each state who were born outside the U.S. So we first make a frequency table from the data. Okay, so we take the data, and what we're going to do is we divide the data into equal classes. So these are the classes: 0 and less than 5, 5 to less than 10, 10 to less than 15, 15 to 20. You can see that every one of these classes are equal sized. They're all 0, 0, 1, 2, 3, 4. So that would be 5, and then 5, 6, 7, 8, 9 would be the next, and so on. And then we count up the frequency that's occurring within that class. So then we have these. So we count, or we could do a relative frequency, which would mean we would take 20 divided by 50, 13 divided by 50, and so on, so that we get a percentage here. We're just going to leave it in numbers, and so then we take the 0 to 5, and now you can see this is a regular number line, so we don't label this 0 to 5, we do a regular number line. But now the width of the bar is going to be the width of the class. So we have to make sure every one of those widths are the same, or else it's going to look strange. So, and then we just graph it like a bar. Be sure they're touching. Now, as the last slide said, if for some reason there was a 0 count, then of course there would be they wouldn't be touching. It would just be this 0 indicating there. So that's a histogram. So try not to get it confused with a straight bar graph, because this comes from a frequency table, and we have these groups rather than the individuals. Okay, so what we're going to do now is we're going to describe what histograms mean. So here we have that data, that frequency table, rather that histogram we just made, and now let's go ahead and go through our SOCS to describe it. So the shape, we say that it's unimodal because it has one peak, skewed to the right because this gets smaller here, and most are less than 10%. Well, we have to sort of look back on our data table on that, but you can see that 33 out of 50 is less than 10%. So that helps us if we're looking at the data table. The center appears to be between 5 and 10. The actual, if you calculate it, will be 6.1%. We'll do that in the next section. The spread is from 0 to 30%. Yeah, right. And the outliers, it doesn't appear to be any, because this one's, even though this is small, it's somewhat close to the others, so the center. So what happens if we take that data and we change the classes? Let's say instead of going from 0 to 5 and 5 to 10, we go to half of that, 0 to 2.5, and then 2.5 to 5, 5 to 7.5, and so on. This data actually turns into this, and we can see that the shape, well, it's still unimodal. It still has one peak, and the center, maybe it's a little easier to look. We're looking at sort of the areas. I would say maybe the actual is 6.1, but it looks like it's out in here. The spread is the same. There is this gap because there aren't any from 22.5 to 25, and maybe this looks like an outlier now. So it really depends on the classes that you use when you're doing these histograms. A little warning: use histograms wisely. Here are several cautions based on common mistakes students make when using histograms. Don't confuse histograms with bar graphs. Bar graphs use single, variable, and counts, or relative frequencies. Histograms uses a range of data. So be careful. Don't use counts in a frequency table or percents in a relative frequency table as data. Use percents instead of counts on a vertical axis when comparing distributions with different numbers of observations. And just because the graph looks nice, it is not necessarily meaningful data. Okay, that is section 1.2, and here we learned about how to make and interpret dot plots and stem plots from quantitative data, describe the overall pattern of a distribution, identify the shape of the distribution, make and interpret histograms of quantitative data, and we learned how to compare distributions of quantitative data. Here are your assigned problems. I'll check those next class period. If you have any questions, contact me on Schoology or email me. Thank you for watching.